Welcome to the video about scatter plots. The first question we want to answer is, when do we use a scatter plot? You're going to want to use a scatter plot when you have two sets of data to compare. Examples of two sets of data that you might want to compare would be person's height versus their weight. And if you had a whole class of people's height versus their weight, you could plot one on the x-axis, their height, and their weight on the y-axis, and see if there's some sort of pattern or relationship there. We might want to compare the car ratings or the ratings of two types of cars. Okay, so we plot one type of car ratings on one axis, the other types on the other, and we're looking at who has more higher ratings. Okay, the important thing, see if I can draw a star, is to have two sets of data so that you can pair up the data into x and y coordinate points. Okay, we want to have x and y coordinate points. Let's take a look at an example. Here we want to compare the average monthly temperatures for Vermont and Florida. And this is all in degrees Fahrenheit. And we have all the 12 months of the year, and we have Vermont's temperatures, average temperature, and Florida's average temperature. And we're probably not surprised to see that Florida has some higher temperatures, but we want to see what this looks like on a scatter plot. So you're going to take, each of these and make it into an x and a y point. And so Vermont's going to be our x and Florida is going to be our y. So if I take this first point, I'm going to go to 10 on my x-axis and 55, and I'm going to put a point. So there's my January. I don't need to label it January, it's fine. And then I have February is 12 and 56. So 12 is approximately here and 56, pretty close, a little bit higher than 55. And then we would have 25 and 67. So 25 and 67. Hopefully you're plotting all these points as well. 35 and 78, 35, 78. 55 and 87, so 55 and 87, way up here. Then we're going to have 67 and 90, 67 and 90, about here. 78 and 95, way up here. Another 78 and 95, so we're just going to put it right on top. It's not going to be able to see another point on top necessarily. 65 and 80, so 65 and 80. 45 and 65. And we have 35 and 50. And we have 32 and 50. 32 and 50. Right here. So here we have a bunch of points. Looks like scatter plot. Okay. What would be helpful is if we labeled this to be Vermont temperatures here and Florida's temperatures here, and we put our title on temps. Okay. Whoa. And we can see that in general, as Vermont's temperature goes up, Florida's temperature goes up. Okay, but what's going to be really helpful to do, and let me change the color that I have, is if we can draw in the line that goes through where y equals x. So y equals x at 10, 10, 20, 20, 30, 30, 40, 40, 50, 50, 60, 60, 70, 70, 80, 80, 90, 90, 100, 100. And I'm going to actually grab, since I have the tool, a nice straight line. So if I start here and draw this line in, it's always where the y value is equal to the x value, the x value is equal to the y value. We can see that in this case, okay, Florida's temperatures are always higher than Vermont's because they're above the y equals x line. So this is where the y is greater than the x up here. So it's always that Florida's warmer than Vermont. Here's where y is less than x down here. And unfortunately, and we probably know this instinctually, never is Vermont going to be warmer than Florida. On average, right? We're going with average temps. So this y equals x line is a comparison line. Okay. Let's look at another way we use scatter plots. Sometimes we want to compare something to time. Minutes, hours, days, months, years, anyhow you use time. And we would plot time on the x-axis. This is called a plot over time. So for example, if we want to look at cassette sales versus CD sales for the 80s and 90s, and hopefully you can see that as we move from the 80s into the early 90s, the cassette sales increase a little bit and then decrease just a little bit, sort of holding steady, whereas the CD sales start off really small and start increasing rapidly. These numbers are in hundreds of thousands, okay, so it's not just 800 CDs. I'm sorry, there's a mistake here. This should just be 8, not 800. Wow. I don't know why it's doing that. So that should just be 8 there. Let's take a look at the graph for this. I've set the plot up for you already, so we have the years on the bottom. So this is our years or our time. Remember, it's going to be a plot over time. And this is going to be the sales. And this is, we're going to do cassettes. And we're going to do those in green. Okay, so we're making a little legend over here on the side. So if I look at the cassette sales, and I'm just looking at the table, in 1983 we had 2,368 in hundred thousands, but we're using this in hundred thousands as well, so that's approximately right here. And then in 1985, we had 3,390, so 85, 3,300, maybe about here. And then 4,100 in 1987. And then 4,462 in 1989, 4,400, a little bit less than half. And then 3,601 in 1991, so 3,000 back down again to 600. And then 1993, 3,395, 3,300, a little bit here. And then in 1995, we're down to 2,700. Okay, so in a plot over time, you do want to connect your points. Now, I noticed I did not connect him from 0 because it wasn't at 0 in 1982. We don't know what it was in 1982. So I'm just going to connect the points that I do know. Let's get a different color. We'll do red. So CDs is going to be my red. Just use a little color coding here. And so CDs, remember I said that's supposed to be actually 8. So in 1983, we started with almost no CD sales. And then we had 226 in so we're still way down here. And then we had 1,000, we broke 1,000 in 1987. And then broke 2,000 in 1989. So increasing. Then broke 3,000 in 1991. 3,300. And then broke 4,000 and 4,900 in 1993. So 4,900, we're way up here. And then 7,000 7,229 in 1995. So 1995, we're way up to 7,200. And so if we follow and connect these lines, whoops, probably should be using a ruler, we can clearly see in this plot over time that the CD sales are increasing rapidly, whereas the cassette sales increase some and then decrease back down. Okay, so this is sales data, music sales we'll call it, and this is in 100,000s. Okay, money. So plot over time, we always use time on the x-axis. You don't have this screen, but 2 words, then you need to add to your vocab section. I'd like you to add what a scatterplot is on that blue sheet that you have still, and also what a plot over time is. Okay, you should be able to define those from the notes that you just took. Good luck.